right, everybody see that okay?
Yeah, and we can hear you as well.
All right, who am I? I am Drew Knab, full stack developer at Side of Sports, and I first heard about this topic in 2016, working on PHP. And I built a little application in Laravel at that time using some of the subjects and rules that I'm going to talk about a little bit. So what are we talking about here? Object Calisthenics is a thought experiment and coding exercise. It was devised in 2008 in the ThoughtWorks anthology by Jeff Bay. And it's just sort of building a piece of software under a strict set of rules to accomplish some non-trivial task using about 1,000 lines of code, taking about 10, 20 hours. The rules sort of force us to think in terms of object-oriented programming and using the concepts specific to that, like encapsulation, polymorphism, and abstraction. Why would we want to do that? Well, it sort of makes the code easier to read in terms of passing around objects. And it makes it so that we don't have to make our code too complex when we use things like polymorphism, when we can have objects that can exist in different states. So what Object Calisthenics is not. It's not an endorsement of object-oriented principles over other paradigms like functional programming. I like functional programming. It is not a prescriptive set of commandments. It's not, you're not going to do this sort of exercise and then write code this way forever. It's sort of get you thinking and get you thinking critically about how and why you write software and structure it. And it also will not make us a better programmer. It's just one of those things to really make you think about how we write code. So the rules. One level of indentation per method. We try not to use the else keyword whenever possible. Wrap all primitives and strings in a class. Use first class collections. Try to use one dot per line. Try not to abbreviate. Keep all of the entities we use small. No classes with more than 2 instance variables, and no getters, setters, or properties. So one level of indentation per method. Methods should do one thing, and that one thing could be act as a control structure or act as a block of statements. So you have some input, you have some output, you have a method that changes the internal state in some way. And indentation means that we are nesting control structures or blocks of statements. Each of these introduces a new thing for our method to do. Some examples of that are something like this, where we check some bool, run through a for loop as our first array in a multi-dimensional set of data, where we have rows and columns. And then we loop through the second, and then we check and see whether that is valid or not, and then parse it, insert it into a DB, or if for any reason we want to log a failure, we could do that in an else block. As you can see, there's 5 levels of indentation here. 0, which is free because when we declare a function or a method, it immediately has some like a single level of indentation. And then it goes from there. So what this does is it increases the complexity and the things you have to store in your brain when you look at the method. We could write it in a way like this, where we break up the individual functionality into a set of other methods where we act on little bits at a time. And it's a little easier to parse what each one does, and it can increase our ability to reuse that code in another area. Don't use the else keyword. This forces us to simplify conditional logic, where we don't have multiple levels of nested if else, if inside of the if else, and have this massive sort of pain train of conditional statements, and maybe there's a switch inside of one of the else's. So we can use specifically something like TypeScript, where we can replace many such control structures with polymorphism. So for example, we have an if else, else if, else, and so on. Whereas we could instantiate and declare some abstract class to do a thing, extend some class to do a specific thing, and then another class extending some class to do a different thing. And then instead, we could call that same function before and pass in the using the type sum class, where what we declared over here, something 2, for instance, and pass in that object and just do the thing. Wrap all primitives in strings. Primitive data types should be wrapped in classes in this case. This gives semantic meaning to the properties so that we're not working on something that is an int. When we're thinking about something in terms of like, well, money or hours or somebody's name. And having that semantics gives us the ability to have our IDE sort of yell at us if we attempt to put an hour as an argument into a function that takes money, for instance. Under the hood, it's all numbers, but we're acting as if it has an inherent semantic meaning and perhaps behavior. For example, money, hour, name, and we're setting these as private. Amount is just a number. Hour is a value.
Hey Drew,
S name first name.
which IDE are you using, by the way?
In this case, it could be VS Code. When I go through this project and work on it, I would be using VS Code to write TypeScript.
Gotcha. Okay.
Well, these principles are available in any object-oriented language that has strict typings. So it doesn't necessarily work in vanilla JavaScript where you would have to guarantee type safety on your own, but it will work in something like if we use TypeScript, where we sort of guarantee at the compiler level the strictness over types. Does that make sense?
I so love static typing. I'm so guilty of just leaning towards those languages, but when I try and debug JavaScript, it's just like on Node.js, it's a crazy call stack by comparison.
Sure, absolutely. So in the process of doing that, we do have the ability to have the compiler yell at us when we make a goof 'em up. And examples, okay, first class collections. So as Peter was talking about in his Lodash presentation there, we do want to keep the contents of a collection to a particular type. And we want to additionally make that collection be a class within our code base so that any sort of loops, adding, removing, filtering, mapping, joining, any sort of behaviors that we would want to do on that collection is a behavior in a method rather than acting on it directly through a series of in JavaScript, the dot notation. So instead of doing like given some class name, details dot filter dot map, and then so on and so forth. One dot per line. If we have to dot into an object too far, we have probably misplaced our behavior. So if in an example, we have a user, and that user has details. If we want to update something about the user's details, if we have to go user.details.update, then we probably ought to have written something on users class to handle that. So we could do users.update details and then execute something on details.update to pass that down through as part of a thin wrapper, as opposed to drilling down into details through user to do that same action. Don't abbreviate. This one is sort of an obvious thing. So just like resisting abbreviating classes, methods, and variables. Think about why you would want to abbreviate in the first place. Is it because you're writing it a lot? Perhaps you need to abstract that functionality. And for instance, one of the things prescribed is a naming convention of order.ship rather than order.shipOrder. Because that duplicates context, we already know that we're working on an order. We don't need to specify order twice. Keep all entities small. Entities are the classes and any interfaces that we might have, and try to keep them below 50 lines. That forces us to kind of think about what needs to go where and how we break up our behaviors and our classes, and how we structure our code. Addition to that, no classes with more than 2 instance variables. This is probably one of the hardest ones to follow, and it leads to a lot of interesting and complex decisions. It relies heavily on rules 3 and 4 to decouple classes. And we're trying to really avoid cramming and adding more and more data to a single class. Users tends to be a place where functionality just kind of gets dumped. And it turns into like this 3,000 line God class where it's really hard to parse as a person walking into it, what's happening, what's going where. If I edit something here, is it going to change something somewhere else? So we're really trying to avoid situations like that. And we might end up with a structure something like, so you have a customer class, and then we have a customer ID class, and that's just a thin wrapper around JavaScript's interior number primitive. And then our second one would be another class, details, and then we'd have a subclass there of name, and then first and last as a thin wrapper around string primitive, an address, etc., and just sort of drill down with these classes acting as instance variables. The last one, no getters, setters, or properties. So a large part of the The exercise is to encapsulate data, and getters and setters and properties hinder sort of the idea of like a perfect encapsulation. So we must have some way of returning the internal state of a class. We just sort of have to do it in a safe way. I included 2 links at the bottom here to some resources. The tell don't ask, where we're going to tell something like our user or customer class to update something in details, for instance. And there should be some sort of internal mechanism to customers or details to handle some sort of validation and handle behavior of how that's updated if it's saved to a database. But we're not directly setting those values as a setter or as a property on that class. Another example would be if we were to be writing a game, if we were to destroy an enemy and update the score, we wouldn't update the score directly by saying like game score dot value equals game score dot value plus the delta of the new score. We would just pass that in as a behavior. So to review, 1 level of indentation per method, because we're attempting to decrease the amount of complexity in a given method, avoiding the use of the else keyword, because we are trying to decrease the amount of complexity in control structures, wrapping all primitives in strings so that we have a semantic idea of what our instance variables are. First class collections so that we can control our collections through behavioral methods. 1 dot per line, so we're not reaching across classes inside of the class we're calling. Don't abbreviate. Keep all entities small so that we have classes that do one specific thing. No class with more than 2 instance variables so that we distribute the data and behaviors across different classes. So we don't have one massive unreadable class, and no getters, setters, and properties to really drive home that we're attempting to encapsulate this data. Most of the rules attempt to achieve encapsulation of data and minimal code duplication. Some of them are just sort of common sense if you're working on any sort of team. And it forces us to really evaluate when to use object-oriented programming and data structures. And if given 10, 20 hours and 1,000 lines of code, these constraints can definitely force us to think about how we write code and structure software.